This is section 3.3, and it is about complex numbers. And the really cornerstone for this section is right here in this box, properties of the imaginary unit I. So up until this point, we've not been able to deal with a radical, a square root, and a negative number, because there is no number in the world that multiplied by itself will give us a negative number. So it was just created, and they said that we're going to call the square root of -1 I. We're just going to make that the name. And then if you square a radical, you get what's inside. So I squared would be -1. Those are the two properties that you're going to be encountering in this section. Let's talk about complex numbers. So every number in the world can be written in the standard form a plus bi. That makes a complex number, where a is the real part, bi is the imaginary part. So let's look at some examples here and see. Trying to get this to move. It's not wanting to. There we go. So I've got some examples of some regular numbers, and let's make sure we can write them as a complex number. So 5 we could write as 5 plus 0i, and -5 minus 2i, that's already in the right form. -3i, we could write it as 0 minus 3i, and then this one is also in the right form. And then I'm just asking you to pull out the a and the b here, and so we have 5 and we have 0 and -5, -2, 0, -3, 4, and 6. So even plain number, a real number or a plain imaginary, can be written as a complex number. Okay? All right. We don't leave radicals that have a negative number in them. We try to rewrite them as I times the square root. In other words, if we had square root of -7, that's the same as the square root of -1 times the square root of 7, and we know now that this is called I, so we would end up writing that as I square roots of 7. That's what this little rule says. Okay? All right. The other thing that we need to know is that complex numbers, we have to deal with conjugates. And that means that every complex number has a conjugate. It has a partner. The only thing different is the sign. If you notice here, this one has a plus, this one has a minus. Those are conjugates. And if you multiply conjugates, you get rid of the imaginary part, so that they come in handy in that. All right, so all you have to do to find the conjugate is change the sign on the b. All right, in this section also, we're going to do some operations with complex numbers. Some of that we'll do by hand, and some we'll do on the calculator. It'll be up to you. If you like doing it by hand, you could do all of it that way, but I think you'll find the calculator to be a nice tool. All right, when you're adding or subtracting, you want to take care of the real parts and then do the same with the imaginary, whether it's adding or subtracting. So in this case, we'd have 3 plus a -5 and 2i minus 6i. So that becomes what? -2 minus 4i, and so that would be the answer if we added those. All right, now multiplying gets a little bit, it can get a little bit complex, because you have to, it's like FOIL, you do the first ones and the outer ones and the inner ones and the last ones, and you combine the things that are the same, and so it takes you a few steps. But we can do this on the calculator, and let me get my calculator going here, because you can see the screen that I drug here from my emulator, but let's get it up. Okay. All right. So we'll second quit out of that. And you can see, let's just clear that and put that in again. Down here above the decimal is an I. So second and the decimal does give you the I. So if we put that in, well, and I've done it right here, negative, well, I guess that's a different one. Well, good. Let's do this one. -2 plus second decimal, close parentheses, open parentheses, 1 minus 2 second decimal, close parentheses, enter, and our answer would be simply 5i. Okay? All right. Now I just did a different one there. I have no clue why I did that, but anyway, you'll get some practice in doing that. All right, the only other thing, the new thing that we're going to do is solve quadratic equations that will end up with imaginary numbers. Okay, so we have this quadratic here. You're familiar with the quadratic formula at this point. A is 1, B is 3, C is 5. So we plug in the parts that we have. So we have a -3 plus or minus square root of 3 squared minus 4 times 1 times 5 all over 2 times 1. And then we begin to clean that up. -3 plus or minus square root of 9 minus 20 over 2. -3 plus or minus square root of -11 over 2. All right, and here's where we recognize that we can't leave that like that. And so our final answer would be that. Okay. All right, I think we've gotten the main ideas. Let's practice. A lot of these problems will go really quickly because they're not bad, or you're using the calculator, and they should be pretty quick. So if you have a perfect square and it has a negative inside the radical, you think about what's the square root of 25? It is 5, so we're going to have 5i. That's all that would be. How about square root of -81? We're going to have 9i. But now the square root of -3, that's not a perfect square, so remember this one becomes I square roots of 3. All right, -112. All right, let's take that over here. Square root of negative, give myself room. Square root of -112, and we need to break that down. We know that that's square root of -1 times the square root of 112. Now can we break that down further? And you want to look at your powers chart and see if there's a perfect square that would go into that. And actually 16 does. It's kind of a trial and error for you. If you tried, 2 and then you'd get another 2, you would find that 16 does go into it. All right, and so it does go into it 7, and this is 4, and here's your square root of 7, and here's an I. So this is our final thing, and we're going to write it as 4i square roots of 7. All right. This one says simplify by using I. So we've got a square root of -72. Let me give myself a little bit of room here. Square root of -72. We know we're going to have an I square roots of 72. And then this, the biggest perfect square in 72 is 36 times 2. So what will we have? We'll have 6i square roots of 2. Okay, so let's see, we've got -9 plus or minus 6i square roots of 2 over 3. Now we need to recognize that 3 can go into all of these. You want to make sure that if you're going to do any canceling that it works for everything. Okay? So what I'm left with is negative 3 plus or minus 2i square roots of 2. Now when you do that right here in this box, you have to separate. So you would have negative 3 plus 2i square roots of 2, comma, negative 3 minus 2i square roots of 2. And that would be in this box. Okay? All right, number 6. We're just adding. And so we're going to add the real parts and get 8. And we're going to add these and get 5i. So that would be our answer. We are multiplying here. We're just distributing. So we really can do that without the calculator. 5 times 9 is 45. 5 times 4i minus 20i. Okay. This one, number 8. I'm going to do that on the calculator, and I'll do this one with you. So let's clear that. All right, we've got to open parentheses, 1 plus 4, second decimal, close, open, 2 minus 3, second decimal, and close. So I want to check and make sure I put it in, and I hit enter, and I got 14 plus 5i. Same thing for number 9, and when you do that in the calculator, you end up getting 37 plus 37i. When you do this one, you can put it in just like that. You can put parentheses, negative 7 plus 8, second decimal, close, and hit your squared key. And hit enter. Negative 15 minus 112i. Okay. All right, when you're dividing, you've got the same thing going on. Now, let's try that on the calculator and see what happens. Sometimes we get things that don't convert to fractions or won't work. So let's try it on our calculator. If we're doing this one, we would do 7 divided by parentheses 1 minus I. And that one works okay. We got 3.5 plus 3.5i, and we can go to math, fraction, and enter. Whoops. Sorry. I can quit. It's not liking that. Okay. Can you, well, in some of these they just do, and some calculators will do it and some won't. So let me write this down. 3.5 plus 3.5 pi. The answer that they're looking for is wanting fractions. They don't want decimals. That's where we run into the problem. So 3.5 is the same as 7 halves. And so you would have 7 halves plus 7 halves I. What you could do is try doing it just by one part and just saying 3.5 math, fraction, enter, and it would change that to a 7 halves. So it may not do it in the problem. I mean, it'll give you the decimal, and then you may have to do each part to get that. You could do that, and that would work. Okay, let's try number 12. Let's see what happens on the calculator. Parentheses, 5 plus second decimal divided by open for minus second decimal close. Oh, we got some really big numbers, and I don't know that those are going to convert at all. Okay, so, and I don't think they'll convert either way. On this one, you might have to do it by hand, so let's go ahead and work that so that you have that. Here's the problem as it starts. All right. When you're not using the calculator, your technique is to multiply top and bottom by the conjugate of this. The conjugate, remember, we just changed the sign. All right, so we're going to multiply top and bottom by that. On the top, it's like FOIL. So first would be 5 times 4 is 20 plus 5i plus 4i, I'm just doing FOIL, and then plus I squared. Okay, so that's on the top so far. On the bottom, when you multiply conjugates, you don't have a middle term, so you can just multiply 4 times 4 is 16 minus I squared. Okay, you don't have a middle term. All right, what did we say I squared was? It's -1. If you have a minus -1, it becomes a +1. So on the bottom, we have a 17, and that's the goal. You don't want an I in the bottom. All right, up here, we've got 20 plus 9i minus 1. All right, 20 minus 1 is 19, so we've got 19 plus 9i over 17. They want you to break that apart. And so up here we would have 19 over 17, that's that part, plus 9 over 17i. Okay, so on that one you may have to actually do that work, but there's not very many of those. Number 13, subtracting and simplifying, that's just with decimals. So I believe that you can do that one. It shouldn't be a problem. You're just going to do 2.1 minus 1.8. So when we add those first two, we get 3.9, and then you have 3.6 minus a negative, so it's actually plus 2.1, so that's going to be 5.7i. So you can do those by hand. All right, number 14 says to solve this equation and write the answers in standard form. So the first thing we need to do is distribute and kind of get that cleaned up. So let's do that business here and get the 13 over here. So we got x squared plus 6x plus 13 equals 0. Now it's okay to say a is 1, b is 6, c is 13. We're going to do our quadratic equation. So x equals -6 plus or minus square root of 6 squared minus 4 times 1 times 13 all over 2 times 1. We'll clean that up. What do we have inside? We have x equals -6 plus or minus 36 minus 52 all over 2, and then we have x equals -6 plus or minus square root of -16 over 2. Well, that's a perfect square, so that is equal to -6 plus or minus 4i over 2. All three of these numbers can be divided by 2, so we are left with -3 plus or minus 2i. And you would need to separate it when you put it in Math Lab. All right, number 15. Same thing. So let's go ahead and work that one. A is 1, B is 2, C is 3. So we've got x equals negative 2 plus or minus square root of 2 squared minus 4 times 1 times 3 over 2 times 1. Clean that up. And you have to rationalize the square root of negative 8. That's 4 times 2. So we're going to have x equals negative 2 plus or minus 2I square roots of 2 over 2, which ultimately gives us negative 1 plus or minus I square roots of 2. Okay. All right. Number 16. Use the graph to predict the number of real zeros and the number of imaginary zeros. All right, what we need to note it here is that this does not hit our x-axis at all. So remember, that gives us 0 real solutions. The number of complex zeros would have to be 2, because every quadratic has 2. If you have no real ones, you're going to have 2 imaginary or complex ones. So then it wants you to solve this. So the equation's right here. So we have y equals x squared minus 3. So a is 1. I think I wrote, is that a negative there? Yep. All right, I think that is a negative x squared minus 3. I think I just wasn't seeing that. So a is negative 1, b is 0, c is negative 3. So let's do the quadratic formula. X equals 0 plus or minus square root of 0 minus 4 times negative 1 times negative 3 all over 2 times negative 1. So x is plus or minus square root of, we got 4 times 3 is 12. We got 3 negatives, that's a negative 12 over negative 2. That's plus or minus 2I square roots of 3 over negative 2. Sorry. X equals plus or minus I square roots of 3. And that should be what goes in our box up here. We're going to have I square roots of 3, comma, negative I square roots of 3. And that should get you done with section 3.3.